So the explicit rating. So you can see, you can look at the ratings obviously, but there is another rating, we call it implicit ratings. So it is typically collected by the web or application in which the recommender system is embedded. So for example, when a customer buys an item, when you already buy the item, the recommender system interpret this behavior as a positive rating. So if you look at the first part of this course, I gave you the example, the small quiz. Okay, you still remember? This one. Okay, what does it mean? Yeah, this is very simple. If Alice buy and he like this one, this one. If there is no rating, I can just give like if the person Alice buy this item, okay, it means he like the product. But other maybe zero or no rating. So that's some website or some application to that one to give the rating, and we call it this is implicit rating. Implicit ratings can be collected constantly.
Yeah, they told me that it's not possible because it overlaps with another code,
Oh,
so it won't be possible. But thank you so much for the opportunity.
okay. Thank you.
Got it?
Yeah. Okay. So yeah, implicit ratings can be collected constantly and do not require additional effort from the side of the users. What does it mean? For example, clicks. Do you know clicks? Okay. When you do the clicks, it means, yeah, let's say I'm going to our school website. When you click here, then it is recorded, one click. And then let's say you click again here, then it is recorded again. So every click, we can look at the user behavior. So this is rating. It means I know that the user have interest on that information. And page views. Okay, how many times the page has been viewed? For example, in the e-class, I can see how many of you stuck on this. So it means okay, 60 times has been viewed. So the number of students are not more than 60, but I can see that okay, 60 times the user already clicked in the site. Then it is also another implicit rating. Time spent on some page. So some of the website or the application, they look at the time. How long have you been in the particular website? So it can be also the implicit rating. If you are very long in the particular website, it means you have interest. If the time is short, maybe only 1 or 2 seconds, then you may have no interest. Or the number of downloads. If you download one application Okay, so you can look. If the number of downloads are many, then I can say it is interesting for the user, or the rating is high. Okay, the download usually it is for the open source. If you look at the GitHub, okay, for example, let's say I have the GitHub recommendation system. So you can look at this one on the start. So the start, yeah, it is kind of rating in the GitHub. And then in some other libraries, they use the number of downloads. Okay. So you can use this one to say like, yeah, how to recommend the GitHub content to developer. Yeah, that's also another interesting topics for the implicit ratings. But the main problem, one cannot be sure whether the user behavior is corrected in the web. For example, yeah, I do not know why there are 60 clicks on the e-class like this one. I'm not sure why the students only 20 and there are 60 clicks. So it is not easy to interpret. And for example, a user might not like all the books she or he has bought. The user also might have bought a book for someone else. Okay, for example, I buy the book, but I do not read the book. I buy the book for a present. I buy the book for the birthday present. Then it is not possible to look at this kind of behavior. So implicit ratings can be used in addition to the explicit. So for example, question of correctness of interpretation. For example, I know the rating is 5. So I want to know how many times the person clicked on the website. So if I have the dimension, the number of click of this rating is 10. Okay. So I can make sure that yeah, it is true. The rating is 5 because he or she has more interest because of the number of clicks has 10. When we deal with the ratings, yeah, there is a problem about data sparsity. The data sparsity means this one, sparse. We do not have rating on some items. So there's another issue, we call it the cold start problems. What does it mean? Cold start. How to recommend new items? I have a new product. So nobody buy the product. Then how can I know who will buy this product? So it is an issue in the cold start problem. And what to recommend to new users? So if you look at some application, usually they give you coupon. Okay, if you join maybe Kupang for the first time, then they will give you Manon coupon to buy. So they want to know what is your interest at the first time. And then after that, they can recommend you to some items. Okay. If they do not have your profiles, then they cannot recommend items. That's the way to do with the cold start problem. they will have some straightforward approach. What is this? So ask or force users to read a set of items. As far as I remember, some of the applications in Korea, they will give you a kind of point if you give rating. Okay, so as far as I remember, like the Gmarket, they give you point if you put review. Okay. So you can ask or you can force the user, please give rating. If you give rating, I will give you point for your next purchase. Or you can use another method. In some of the application, they will ask you, what is your gender? And then how old are you? Where do you live? So they can know about the demographic. Or they can also look at the content. For example, you can mention about yourself. Or yeah, simply non-personalized in the initial phase. Yeah. So usually in the initial phase, some website they give questions. Or default voting. It means assign default values to items that only one of the two users to be compared has rating. So like this one is the default voting. Voting means, yeah, if you are the new users, okay, yeah, I think you know in some website they distinguish between LinkedIn, Webkin. So if it is Webkin, then they can recommend some items for the Webkin. Maybe they know that, okay, for the foreigners, they like items from the import countries. So for the Negukin, for the Korean, they like items that are now is popular. So they have like the default coding like that. So the alternative, yeah, we can use better algorithms. Using the better algorithm means beyond the nearest neighbor approaches. So I think next week we will learn more algorithms, not only the nearest neighbor. So what we already did today is the nearest neighbor using the similarity. The nearest neighbor approach, the set of sufficiently similar neighbors might be too small to make good prediction. Sufficiently similar neighbors. So we assume that our data is completed. So every users have rating. But it is a little bit difficult if some data are not good. And yeah, we can assume the transitivity. The transitivity. I think in the data structure, we also learn about this transitive. It's in the graph, we call the transitive closure. Okay. So let's see, what is this transitivity? Some algorithms for the sparse data set. So if there are so many missing data, so like this one, we have the missing data. So one approach, they use the recursive. Do you know recursive? Okay, this is also from the data structure. We learn about the recursive means we want to repeat. Okay, repeat. Assume there is a very close neighbor n of you who, however, has not rated the target item yet. So I want to predict what is the rating for item 5 of Alice. And I know that Alice and user 1 are very similar on the behavior. So if I can predict the item 5 of Alice, so I can use the same way to predict the item 5 of user 1. So I can do recursive. So it means, yeah, apply the CF method. This is the collaborative filtering method recursively and predict a rating for item I for the neighbor. So after I predict item 5 from the item 1 and item 4 of Alice, I can do the prediction on item 5 of user 1 from the item 4 and item 1 of user 1. And then I can do, if there are some other user who do not have the rating on item 5, I can do again with the item 1 and item 4 of that user to predict the rating of item 5. So we call this is the target. The target. So use this predicted rating instead of the rating of a more distant direct neighbor. Because I already have this one, okay. So I can predict this one similarly. Okay, I can use Alice prediction method to predict this one. And then I will check this one Alice and this user 5. If it is similar, then I can use the same way to predict the item 5 based on item 4 and item 2. And yeah, we do recursive. There is another way to predict using the graph. In the graph, we already learned the graph. We have node or vertex and heads. So node is like this one, and then we have heads. So this is based on the spreading activation. What this is? We want to exploit the supposed transitivity of customer taste and thereby augment the matrix with additional information. Assume that we are looking for a recommendation for user 1. So now I have the user 1. When using a standard CF approach, okay, let's say this one, I have user 1, user 2, user 3 as a node. And then I have another node, which is item 1, item 2, item 3, and item 4. So the line or DX, it represents that user 1 like item 2, or user 1 has interest on item 2, and user 1 has interest on item 4. In this case, user 2, it has interest on item 2, item 3, and item 4. User 3 has interest on item 1 and item 3. Okay. So when using a standard CF approach, CF is the collaborative filtering that we already learned before, user 2 will be considered a peer for user 1 because they both bought item 2 and item 4. So user 1 and user 2. So user 1, item 2 and item 4. User 2, item 2 and item 4. And there is an item 3. Okay. So at least I know that user 1 and user 2, they are both like item 2 and item 4. So I can say that user 1 and user 2 they are similar. Then I can recommend item 3 because the nearest neighbor user 2 also bought or like it. Okay. User 2 he has item 2, item 3, item 4. How about user 1? User 1 only have item 2 and item 4. And item 3 can be recommended to user 1 because they have some similarity on those two items. So this is the spreading activation. In the standard of CF approach, okay, today you learn about the user base, which is about the user. Or we also can look at the item or the column. So in the standard of user base or item base, the path of length 3 will be considered. What does it mean by path of length 3? So let's see. That is, item 3 is relevant for user 1 because there exists a 3-step path. 3-step path. So for example, like this. User 1, item 2, user 2, item 3. So user 1 to item 2, and then item 2 to user 2, and then user 2 to item 3. We have 3 steps because this is 3 steps. 1, 2, 3. Because there is a 3-step, then I can say that it is still possible to recommend this item. Because the number of suspects of length 3 is small in sparse rating database, so the idea is to also consider longer paths. In the longer paths, it means indirect association. So there is no direct association to compute the recommendation. For example, we can use path length of 5. If we consider the path length of 5, it means we can consider something more like this one. If we use 3, then I can recommend item 3 to user 1. So user 1 to item 2, and then item 2 to user 2, and then user 2 to item 3. But if I use the length of 5, then I can also recommend item 1, because from item 3 I can go to user 3, this is 4, and then from user 3 I can go to item 1. So we have the length of 5. It means I can recommend item 3 and I can recommend item 1 to user 1. So it depends how many lengths you want to design. Okay. So I give the red line. 1, 2, 3. This is length 3. And then 1, 2, 3, 4, 5. This is length 1. Okay. So I think that's all. Okay. I give again another problem for practice. You can practice at home. And next week, as like today, from 9 until 9:35, I will be here, and we will discuss about the practice 1 and practice 2. Okay, so if you can come and join me at that time, yeah, we can discuss like this. I hope one student or two students can solve the problem like this one. But I will also record. So if you cannot come, you still can see the video. Okay, I will post later in the class so you can watch again the recorded video. There are two practice. Okay. The number of reading is similar, but the practice number 1, we need to fill in the missing value. How to fill in the missing value? So I give you this kind of way. So fill in the missing value with the average on the respective users. Okay, so you can fill in with this with this user. And yeah, because we want to predict this one, yeah, you can just skip to fill in this missing value, and then after you have the average, you can round. Okay, maybe it is for easier for the computation. You can make it round up value. For example, if the value is 4.1, then you can round to the nearest integer. This is 4. If the average is 3.6, yeah, it is more than 0.5, then you can round it to 4. So please use the Pearson correlation to find the similarity of user. And let's predict the rating based on the 2 nearest users. The idea is the same with this one, but this is a complete rating. So you don't need to fill in the missing value. And you also need to use the Pearson correlation and predict the 2 nearest users. And let's see what is the difference between those 2 results. Okay, we already finished the concept about CF, and we know about the user base, and we learn about the Pearson correlation, we learn about the item base, and we learn about the cosine similarity and the adjusted cosine, and we learn about the data sparsity problems and how do we handle the data sparsity problems. Okay, any questions?